Hey, it's Dan. Let's talk parent functions of quadratics and some shifts and stretches and compressions and that sort of thing. So consider the parent function f of x equals x squared. And this would be the graph over here for this one. So the vertex is at 0, 0, and it's going up. And 1, 1 is a point, 0, 0 is a point on the graph, negative 1, 1 is a point on the graph, 2, 4, and negative 2, 4. Those are all points on the graph. So we call that the parent function of a quadratic. So the question is then, what happens when you have these babies over here where something else is going on? So there's the parent function. F of x equals x squared, and this is what the graph looks like here. So let's talk about these. Well, first of all, the fact that you have a number out here, we call that a vertical stretch by a factor of 2. Because this number is positive, the graph is opening upward rather than downward. So this is going to be a vertical stretch of 2. It's like if you grabbed this and stretched it up vertically. So the graph of this is going to be thinner because you vertically stretched it up. If this was elastic and you grabbed it here and you stretched it vertically up, it would get thinner. Notice the x minus 3, this means it's shifted to the right 3. So this graph is going to look like this, except it's going to be thinner because it's a vertical stretch. And it's going to be shifted to the right 3 and up 5. So this graph actually looks like this. So notice it's to the right 3 and up 5, the vertex is. So the vertex is at 3, 5. And it's a little bit thinner than that one up there because of this 2. So then the next question is, well then what would this look like? See the negative? The negative means this graph is going to open downward. So it's going to look like this right here. It's going to open downward. And because it's 1/3, it's a horizontal compression or vertical. It's a vertical compression, excuse me, because of the 1/3. So this is a vertical stretch because it's 2. But if this number is a fraction between 0 and 1, it's going to be a vertical compression. So it's as if you vertically you took it and you compressed it, and it would thicken this out or widen it out. So with 1/3, the graph is going to be thicker or wider. With the 2, the graph is thinner than this. So the negative means it's going downward. The 1/3 means it's going to be thicker or wider. The plus 2 means it's shifted to the left 2, down 6. So the number that you have tacked on here on the outside of the parentheses is vertically shifting it to the up or down. So this is down 6. This was up 5. This was to the left 2. This was to the right 3. So that's how that works out. So this graph is down here. So this is a little bit about quadratics, the parent function, x squared, and vertical compressions, vertical shifts, and horizontal shifts, and that sort of thing. There's a whole lot more to say about graphs. I mean, you could do the same thing with the square root function. You could do similar things to the x cubed function, so forth and so on. So I hope you'll think about these shifts and stuff. Basically, once you understand how the compressions work and the horizontal shift and the vertical shift, it's going to be the same in the other types of parent functions. And so your teachers are trying to get you to see that pattern so that on every single problem, you don't have to graph it on your graphing calculator to kind of figure out generally what the shape is and where it's going and that sort of thing. So they don't want you to have to graph it. They don't want you to have to make a table of values every single time. Not that there's anything wrong with that. These are good ways to understand what's going on with a graph. But they would like for you to kind of already in your head have a good idea or a good indication based on what you know about the equations, how the shape's going to go or what the shape is going to look like. Anyway, so these are things that you should have learned in a little bit in Algebra 1. Definitely in Algebra 2, these things show up in college algebra and pre-calculus and other courses. So these are things that every good Algebra 2 student understands and has down pat by the end of the course. Hey, do well on your final exams.